Hello and welcome to my video lesson 1.4 on fractional and decimal exponents. So we're going to go through what these look like and how to change them into a radical. So first of all, fractional exponents are simply just using numerators like a normal exponent and the denominator as the index for the radical. You can write these as any of three different ways, and all of them are true. Okay? We usually prefer to see it like this, just visually it looks nicer as one of these two. Okay? But which one is easier to use in a given situation really depends on what the situation is calling for. Usually in terms of calculating it, this one is the one we can calculate with. So that's usually what we'll convert it to. But if there are multiple things with the same base and you're adding exponents, this one lets us add or subtract exponents. So they're all useful for different things. That first one will come up more in the next two lessons, but for today we're going to mostly be going for that last one. Okay? But you should know that all three of these are valid ways of solving these. Okay, so this is helpful because now we can solve more questions by hand, because a fractional exponent looks very gross, but if we change it into a radical, now we can deal with it. So for example, we're going to do this first one here, where we can take a cube root of 8 and then put it to the 4 afterwards. So first of all, finding the cube root of 8, hopefully you can kind of remember that we can do the prime factor tree, so it's 2 times 2 times 2, and if it's a cube root, you take one group of 3 here, and so this would be 2 to the 4. Now that we've done that, we can go 2 to the 4 is 2 times 2 is 4 times 2 times 2 is another 4, so 4 times 4 is 16, and our final answer is 16. Okay, you can see here how much more difficult it would be to do this the other way around. So, for example, if you tried to do 8 to the 4 first and then cube root it, well, it'd be like 64 times 64 cube rooted, and I can't do that in my head. Like, it's just going to be a big number. 64 times 64, 4096, and then it's cube rooted. And so then it would be like, it'd be a process, right? You could see how we'd have to do a big factor tree now of that, and eventually you'd get 16, 16, 16, and 16, and then you could add all of those together, and it'd be a lot of work. We don't want to do that. That's why we stick with the other method when we're calculating it by hand. Okay. Let's try another example. I highly recommend pausing the video at this point and trying the next one here, because it has a fractional exponent. All right, we're going to do it. So we've got 27 to the 2/3. So again, I recommend you do the cube root first, so cube root of 27, and then you square it at the end. So we're going to take 27, we're going to go 3 and 9. We're going to go 9 is 3 and 3, and because it's a cube root, it's all three of those, and so it's 3 squared, and we get 9 as our final answer. Alright, so what happens if we have a decimal as our exponent? Well, basically, you need to change the decimal into a fraction. Some people have difficulty with this, so let me just explain what to do. This is a basic, these ones are basic numbers, but what if we were given a more complex decimal like 0.45, okay? Let's say 0.45. How do we change that into a fraction? Well, what we do is we take the decimal and we move it over however many places we need to. So we moved it over 2 spots. So we're going to put the 45 there now. And because we have to move it over 2 spots, we're going to put a 1 and 2 zeros, so 100. So 45 over 100 is the same thing as 0.45. But this is not a simplified fraction, it's just simply a fraction. So this is going to be 9 over 20, because basically you can divide by 5 top and bottom. Let's maybe write that down. You can divide by 5 here, equals 9, divide by 5 here, and equals 20, and that's how you simplify it. You just pick a number you can divide by. So, yeah, and that would be the simplest you could get, is 9 over 20. But basically, again, the trick is move the decimals and put that many zeros underneath. Now, if it's a 0.5, most people are kind of okay with that because it is going to be just a half. 0.5 is just a half. And if there are 1.5, there are 3 halves. So most people can kind of figure this one out in their heads without what I just said. Okay, now that you found a fractional answer, now we can change it into the radical form, which is square root of 25, and then we're going to cube it. Square root of 25 is 5, and then we're going to cube that, and we get 125 as our final answer. Alright, again, I recommend pausing the video, trying this last question out for yourself, but here it is. So since it is 0.75, you could certainly do it as a fraction if you wanted, so 75 over 100, right? Then you could divide by 25 top and bottom, and you get 3 over 4. So it would be 16 is 3 over 4. 16 to the exponent, 3 over 4. So now what we're going to do is the same as what we've always done, which is root 4, which is the denominator, and then of 16, and then to the exponent for the numerator, which is the 3. So root 4, or fourth root, sorry, of 16, well, what we're going to have to do is figure out what that is. Here's the prime factor tree. I'm just writing it out really quickly. But you can see that we have 4 2's, so that means the answer is 2. So 2 to the exponent 3, which is 8. So our final answer is 8. So this is getting obviously very nice, beautiful answers. Let's try one more example with a number that is maybe a little bit more complicated. Oh, whoops. Maybe using I'm going to put a 2 here. I'm going to put a 5 there, and I'm going to put a 24 down there. Okay, so this is a slightly more complicated question only because it is going to require having a mixed radical as an answer. So 24, so first of all, actually, how should we write it? We should write it with the square root of 24, since it is a 2 denominator, and then to the power of 5. But we don't know the square root of 24, so what we have to do is we have to break 24 up into its components. So 4 and 6, 2, 2, 2, and 3. Now what we can do is rewrite it out. This is probably the best way of doing it for now. If you can do this one step faster, that's fine with me. But for now, I'm going to write it all out just like that so that we don't make a mistake. Noticing that we're going to take a group of 2 of them and we're going to put them on the outside. We're going to put a group of the 2 times 3, which is 6, on the inside. Okay, and now we've got that 5 up top. So we're still going to have to deal with that 5. So we're going to, if we do 2 to the 5, we're going to get an answer of, well, basically, let's write it out like this, actually, so we can all see it. 2 to the 5. Okay, and then if we were to do that, 2 to the exponent 5 is 32. And then square root of, and then 6 to the exponent 5 is 7776. And so this is our final answer. Alright, so I hope this video helped you better understand the fractional and decimal exponents and how those basically end up giving us exponents and radical work to do. Hope this video helped, and good luck.